Good day! Our lesson for today is illustrating and simplifying rational algebraic expressions. This is under week 3 of quarter 1. I am Ms. Geraldine Grace Garcia, your Mathematics 8 teacher. Learning objectives. At the end of this lesson, the learners are expected to illustrate rational algebraic expressions and simplify rational algebraic expression. What do you mean by rational algebraic expression? By definition, according to Khan Academy 2020, a rational algebraic expression is a ratio of two polynomial expressions. It is in the form of fraction p over q, where p and q are polynomials, and q is not equal to 0. The rational expression is undefined for the values that makes the denominator equal to 0. But what do you mean again by polynomials? Polynomials are sums of terms in the form of k times x raised to n, where k are all real numbers except 0 and n is any whole number. Take note that variable x can be replaced with other variables. Also, in any polynomial, no variable should be in a radical symbol. Now let's identify if the following sets of algebraic expressions are polynomials or not. Our first set of algebraic expressions, you have x cubed minus 1, 6, a squared plus 2a plus 1. Yes, these are polynomials. Our second set of algebraic expressions, we have the following: x squared minus 2 square root of x and 5x raised to negative 2. These are not polynomials. Notice with the first given algebraic expression, x squared minus 2 square root of x, in the second term, variable x is in a radical symbol, specifically a square root. So, the exponent of x is 1/2, which is not a whole number. For the second given, variable x has an exponent of negative 2, which is also not a whole number. Jenny and Rose decided to play a sorting game. They have cards wherein rational algebraic expressions and non-rational algebraic expressions are written. Let us help them sort these cards by separating rational algebraic expressions from non-rational algebraic expressions. We can achieve this by following the definition of rational algebraic expressions. So again, what do you mean by rational algebraic expressions? This is the ratio between two polynomials in the form of p over q, where p and q are both polynomials and q is not equal to 0. So let's have those cards. Let's have our first card. Our first card contains square root of x over 5y raised to negative 2. Is this a rational algebraic expression? No. The numerator and the denominator are both not polynomials. Notice that the numerator is square root of x, meaning the exponent of variable x is 1/2, which is not a whole number. The denominator, 5y raised to negative 2, has a variable that is raised to negative 2, which is not a whole number. Our next card contains 2 square root of 2x over 5x, where 5x is not equal to 0. Is this a rational algebraic expression? No, it's not a rational algebraic expression. The numerator is not a polynomial because of the square root of 2x, which indicates that the exponent of 2x is 1/2. Take note that the exponent of the term or terms of a polynomial should be whole numbers. There should be no any variable in a radical symbol. Our next card contains 2x over 5y, where 5y is not equal to 0. Is this a rational algebraic expression? Yes, it is a rational algebraic expression. The numerator and the denominator are both polynomials. It is also indicated that the denominator is not equal to 0. Our next given is 2x plus 2 all over 5y plus 3, where 5y plus 3 is not equal to 0. Yes, this is also a rational algebraic expression, since the numerator and the denominator are both polynomials. It is also indicated that the denominator is not equal to 0. Our next given, 2x squared plus x plus 1 all over x cubed minus 1, where x cubed minus 1 is not equal to 0. Again, this is a rational algebraic expression since the numerator and the denominator are both polynomials. It is also indicated that the denominator is not equal to 0. Our next given is x squared minus 2 square root of x. This is not a rational algebraic expression since the numerator has a term of 2 square root of x wherein the exponent of x is 1/2 and 1/2 is not a whole number. Our last card is x squared minus 1. Yes, this is a rational algebraic expression. The numerator and the denominator are both polynomials. 1 is automatically the denominator of the given. Take note that all polynomials are rational algebraic expressions. So to summarize, all cards in color green are rational algebraic expressions, while those cards in red are not. Remember, to determine if the given expression is a rational algebraic expression or not, first, you have to check if the given expression is in a fractional form of p over q. The numerator p and the denominator q should be both polynomials. Please recall the definition of polynomials. And lastly, the denominator should not be equal to 0. Simplifying rational algebraic expressions. To help you understand simplifying rational algebraic expressions better, you need first to master and/or review the following concepts. First, reducing fractions to lowest term. Second, law of exponents. And lastly, factoring polynomials. To recall on how to reduce fractions to lowest term, you may watch this instructional video. To recall factoring polynomials, you may watch the following instructional videos. To recall law of exponents, please refer to this given table.